Welcome to SRA 221. In this lecture, we will continue our discussion about malware and other forms of attacks. We will take a close look at viruses and prevention detection techniques, as well as buffer overflow attacks. The virus structure has three parts. The first, infection mechanism, is the means by which the virus spreads or propagates, enabling it to replicate. Next, we have the trigger, which is the event or condition that determines when the payload is activated or delivered. Finally, we have the payload, which is what the virus actually does. The payload may involve damage or may involve some benign intent, but it will be noticeable activity on the user's computer. Depending on the location of the virus can be pre-pendited, post-pendited, or embedded within the software and some other fashion. The key to its operation is that the infected program, when invoked, will first execute the virus code and then execute the original code of the program. In order to stop a virus, there are a couple main strategies. The first one is to try to prevent the virus from infecting the machine in the first place. The second one, which is a little more feasible, is to avoid letting the virus propagate widely and make the machine less vulnerable. In this slide, you will see a common virus structure. You will see at the top of the code that the name of the virus is V, and it is assumed that the entry point to the program, when invoked, is the first line of the program. The first line of code is a jump to the main virus program. The second line is a special marker used by the virus to determine whether or not the potential victim program has already been infected with the virus. Next, the virus may execute its payload of the required trigger conditions, if any, are met. Finally, the virus transfers control to the original program. It is important to note that if the infection phase of the program is rapid, the user is unlikely to notice any difference between execution of an infected and uninfected program. Everyone dreads being the recipient of a computer virus, which is why it is important to note each of the different types of viruses that are out there. A boot sector infection means that the virus infects a master boot record and spreads when a system is booted from the disk containing the virus. A file infactor means it infects the files that the operating system shares and is considered to be an executable. Macrovirus infects files with macro or scripting code that is interpreted by an application. An encrypted virus is where a portion of the virus creates a random encryption key and encrypts the remainder of the code. The key is stored within the virus, and when the infected program is invoked, the virus uses the stored random key to decrypt the virus. Next, we have a stealth virus. This is a form of virus explicitly designed to hide itself from detection by antivirus software. The entire virus is internal. This could use code mutation, compression, and the rootkit technique to achieve this. A polymorphic virus is a virus that mutates with every infection, making detection by the signature of the virus impossible. Finally, a metamorphic virus mutates with every infection, just like the polymorphic virus. The difference between the two is that the metamorphic virus rewrites itself completely with each interaction, increasing the difficulty of detection. This virus is able to change its behavior as well as its appearance. So you may be wondering, what can I do to protect myself from viruses? The ideal solution to the threat of viruses in general is prevention. Not allowing the virus to get into the system in the first place or block its ability to modify the system is the best approach to avoiding viruses. However, it is generally nearly impossible to achieve, but taking suitable countermeasures to harden systems, educating users, and preventing an infection may significantly reduce the number of successful virus attacks. Realistically, what we need is a few mitigation options. The first, detection, is once the infection has occurred, determine that it has occurred and locate the malware. The next, identification, is once a detection has been achieved, identify the specific malware that has infected the system. And finally, removal of the virus in its entirety. Once the specific malware has been identified, remove all traces of malware or virus from the infected system so that it cannot spread further. If a user is unable to remove the virus successfully, the entire infected program must be removed from the machine and replaced. Antivirus software is the most common software available to users to prevent virus infection. Earlier viruses had simple codes to execute them, which was easily removable by programs and users. As technology has evolved, viruses have become more complex, so the antivirus software must grow and adapt to the changing environment. We will now draw parallels to worms propagation. Remember that the worms is also a piece of software, but different buyers or more automatically applications self-expand quickly from machine-to-machine connection. A worm usually exploits some sort of security holes in the system. For skins, network from machines specific security hole. Then, when it discovers a vulnerable machine and copies itself into the new machine, propagates from there using security holes. Some means to actually propagate in the network or by electronic mail, file sharing, remote execution capability, and remote logins. Depending on the virus model and the way the virus is programmed, the virus might target specific victims, or it might propagate at random. If it targets specific victims, it may have what is called a hit list, where it might follow specific features of the network where it is being propagated. Worm countermeasures overlap with antivirus techniques. Once a worm is on the system, it can be detected typically through antivirus software. Worm defense approaches, however, focus on network activities because this is the main activity that the worm manifests. Therefore, you may find specific features and antivirus software that monitor network activities to identify worms on an infected system.